Let's find the integral of the following using substitution. So this is the part 2 of the integration by substitution. It is expected that you know the formulas for the integration of simple trigonometries. If you haven't learned that one yet, please watch the video before this video. So let's try to look at the integral of the cosine x sine squared x dx. So in this case, again, you're using the one by substitution. We want to rewrite this one. We want to rewrite this into the form of u to the n du. Because if you can rewrite it in this form, then it's going to be very simple for us to solve it. So the strategy is to take the one with the power. So in this case, this sine squared x. So we can let our u as equal to sine x. Again, we are letting u as sine x because it is the sine x which has the power. Okay? So this one now is equal to what? The derivative of u with respect to x is cosine x. So therefore, this question by substitution will be equal to, so this sine squared x becomes u squared. This cosine x dx is the one that remains there. So we need to find that expression. And from here, what we can see is this one is the same as du is equal to the cosine x dx. So the cosine x dx itself is du. So therefore, this and that is du. So therefore, that question is actually u squared derivative of your u. Alright? Again, let's just make it a bit clearer that you let u as your sine x because it is your sine x as the power. And then you take the derivative of your u with respect to x, then that is cosine x. Then you're looking for the remaining expression in the question, and that in that case, that's the cosine x dx, and that is du. So the du now, this question is actually equal to this. Now we are ready to integrate, and that is equal to u cubed over 3 plus c. But what is your u? Your u is sine x. So therefore, that's equal now to 1 over 3 sine of cube. Your u is sine x, okay? Sine cube x plus c, which is correct. Alright, now let's try to check whether our answer is right or whether it makes sense. So again, when we take the derivative of that, our derivative must be equal to this. Let's try. So this will, in our differentiation, that is equal to 1/3 times 3 sine squared x times the derivative of sine x, that is equal to the cosine x, plus the derivative of the constant is 0. When you simplify this, 1/3 times 3 cancels each other's out. So this becomes sine squared cosine x, which is our answer. So it means that our answer is correct. Our substitution is correct. Okay? Again, this is only the checking part. Let's proceed to the next example, to the next question. Suppose I have the integral of sine x cosine cube x dx. It's actually exactly the same thing there. If you would like to pause the video for a while and try this question by yourself, you may do so. Again, it's the cosine x, which is the power of 3. So we can let your u as your cosine of x. After letting u as your cosine x, you take the du dx, and the derivative of that is equal to negative sine x. Okay? So the integral of we can now do the substitution. So this portion now is equal to the integral. Your u is cosine x, so that is now u raised to cube. And then you have your sine x dx. You want the expression for sine x dx, and you can take it from here. So from here we can see that du is equal to negative sine x dx. But we want only sine x dx, so therefore we divide that 1 by negative. So that's negative du. So this is going to be du, and that's going to be negative of that. So we can now take the integral of this, and the integral of that is negative of u to the 4 over 4 plus c. Now we're ready to plug in back our u. So from there, therefore, our final answer is the negative of the cosine of 4x divided by 4 plus c. That is our final answer. Let us try to take a look of the next example. Let me just call this. Okay, so that example number, sorry. So this one is not included. Okay? So let's try to look at this. Secant squared tangent squared x dx. Again, so here you're going to see that the secant is a power, the tangent is a power of 2. But which of these are we going to use as our u? Is it the tangent x or is it the secant x? However, remember that the derivative of tangent x, remember that the derivative of secant u du is equal, the derivative of tangent u du is equal to the secant squared u, correct? So, the derivative of tangent 2 is secant squared u du. Okay, so therefore, we can actually, using this formula, we may think that our u is that tangent x. So from here, let our u is equal to the tangent x. Okay, by the way, this u there and that u there are different. Okay, this is a formula, so they're actually totally different one. So here we let your u as our tangent x because it has the power, and when you take the derivative of that tangent x, which it will give you secant squared x, which is actually that remaining. Alright, so therefore from here you can see that the derivative of u is equal to secant squared x dx. Now we are ready for substitution. So that is now the integral. The tangent x is your u, so that is your u to the second power, and your secant squared x dx. This remaining expression, secant squared x dx, is equal to du. Therefore, the integral of this now is equal to u cubed over 3 plus c, or putting back our original u, that is now tangent x cubed divided by 3 plus c. So that is our answer. If you would like to check, just simply take the derivative of this and it will give you this one. Right? Let's try to look at the next example. The integral of 4x cosine 3x squared dx. Oh, it's a bit confusing maybe, so let me just cut it there. Okay. Okay, so in this case, as you can see, the cosine, okay, this one here, the cosine is has no power, so we cannot say that the entire cosine is our u this time. However, try to look at this, the 3x squared and that 4x there. Okay, so here, if we can let that angle 3x squared as our u, the derivative of your u with respect to x becomes 6x. Alright? Then let's try to do our substitution. So let's see if our substitution can actually solve this one. So you have there the integral of, so just copy that. So you have the cosine of u. Okay, cosine of u, cosine of u. What we want is the expression for this 4. Let's copy that 4. So what we want is the expression for x dx. So from here, we can see that the du is equal to 6x dx. So the x dx is equal to 1 over 6 du. So therefore this one, we can put that 1 over 6 and that du there. So therefore this is 2/3 the integral of cosine u du. So again, in this example, when we use the integration by substitution, it's no longer in this form of, it's no longer in this form, alright? But when you use the integration by substitution, it gives us these basic formulas. So therefore, the purpose, okay, the purpose of integration by substitution is that the complicated question after using integration by substitution can be written into the basic formulas like this. When I say basic formulas, again, we can say that it's basic formulas if we can write it in terms of sine u du, or we can rewrite it in terms of cosine u du, or we can rewrite it in terms of the secant squared u du, or we can rewrite it in terms of u to the n du. If you use integration by substitution, and you would be able to rewrite the question into this form, therefore your substitution is correct. Okay, so therefore this is now 2/3. The derivative of cosine u is what? It's the integral of cosine u is equal to sine u. So the integral of cosine u is sine u plus c. So therefore the final answer now is 2/3 sine. Let's put back our u, which is 3x squared plus c. So there you go.